look at nested classes and lambda expressions. In this lesson, we're looking at the types of nested classes and static, member, local, and anonymous. And then we'll also study what are the lambda expressions, which is kind of a very interesting way of writing logic in Java through this sort of lambda expression style, which actually relates to the nested classes. Anyway, we'll start with nested classes first. There are different types of nested classes, but what's common between all of these types is that they represent cases when one class is written inside another. And a reason why would you want to do that, why would you want to put one class inside another, is because you want to constrain the context in which it is used. So usually you would like to probably do kind of a more reusable code, right? So introduce a code with a greater degree of reusability. But occasionally you may wish to design some code that is intentionally restrictive in a way that is reused. So you don't want the code to be reused everywhere. You want that a particular class to only be used in a certain context. And that's where you can put the class. You can nest it in another context. So there are several types of such nested classes, and the first type is called static nested, and that's where the inner sort of this nested class is placed inside the outer class in its static context. Member inner class is associated with an instance context of the outer class. Local inner class is associated with a context of specific method, so it's inside the method. An anonymous inner class is just an inline implementation of an interface or an extension of a class. Now, we'll start by looking at this example. There are a couple of examples here. The examples you're actually looking at are static nested in this page, but we'll see other examples in a moment. But first, what these two examples show, well, they both show that there's a class inside a class, right? So there's this outer class, and then there is this nested class, right? And as you can see, there's a word static present on it, which places this nested class in a static context of the outer class. So remember, static context is the one that's shared between all instances, right? However, notice the difference. In the left-hand side example, the static nested class is public. But on the right-hand side example here, this same sort of static nested class is actually not public, it's private. So here's an interesting thing. If you make static nested class private, then a code outside of the outer class won't be able to actually see it. So only operations of the outer class will be able to access that static nested class. So that, for example, outer class provides some kind of method which actually creates instances of the static nested. Yeah, sure, you can do that. But from the perspective of the world around the outer class, well, you would be able to call a method upon the outer class, which presumably internally creates some instances of static nested. Absolutely, why not? But you won't be able to actually see the static nested class directly from outside of the outer class. So you kind of hide that class inside the outer. On the left-hand side scenario here, the class is public, which actually makes it possible to observe it outside of the outer class. We're using this dot notation, outer class dot the static nested class. And actually you can instantiate it directly from outside of the outer class by using new operator, and again using this strange kind of dot notation when one class is sort of inside another. That's your choice. You could decide which way you want to implement this class inside a class scenario, right? You could make it private, you can make it public. That's your call, really. But this is the consequence. Where would you be able to observe that class from, right? Just from the outer class or from the world around the outer class as well. Anyway, well, let's take a look at closer at these examples. So zooming in into the actual example of static nested class, what it feels like, right? So imagine you have this class order, and then for What order represents different orders. Customers can place orders, order products, whatever. But how about orders generally are associated with the way they can be shipped, shipping mode? Maybe fast shipment, normal shipment, priority shipment, whatever. It's just the way to deliver that order. What we're trying to say by creating class shipping mode inside the class order, we're trying to say that shipping mode is something that only used by orders. Nothing else in our application uses that shipping mode. It's only valid in the context of the order. By making shipping mode static nested class, we imply that a specific instance of order has no relation to the shipping mode. It's the overall type order that relates to shipping modes. So each shipping mode is something that belongs to kind of all orders. It's all orders that potentially can use fast, normal, priority, or whatever other shipment. You can create different instances of shipping mode. I'm sure you can. As many as you like, actually. So, yeah, why not? But you can only do it in the context of the order class. Moreover, you just made it private, so no code outside of the order class can possibly see the shipping mode class in the first place. So you could call a static method upon the order, like that create shipping mode method, yeah, and ask the order to create some shipping modes, the order class. But instances of the order, well, they kind of collectively share whatever static context the order has, and the shipping mode instances are all related to the static context of the order. They're not related to specific orders, right, in this particular example. What the code inside a shipping mode can have? Well, it's a normal class, as you can see. You can have variables inside, you can have constructors, you can have other methods. This is like pretty much like any other class, except it's written inside another class. Also, the code inside a shipping mode class can actually observe outer class variables and call outer class methods, even if they're private. So static nested classes, or well, any nested classes actually, can access the code of the outer class directly. However, because the static nested class relates to the static context of the order, the only thing you would be able to see within the order class from within the shipping mode class, if inside the shipping mode you're looking at the order, you only see static methods and static variables of the order. Inside a class shipping mode, you can't address specific orders, like that order or this order. In a way, what you need to realize, the keyword this inside a shipping mode class means an instance of shipping mode. The keyword this doesn't mean this order. It means this shipping mode. So it refers to the instance of this static nested class, not the instance of the outer class. And because this nested class is static, it cannot actually even see instances of the outer class as such. This is not something that you can observe from a static context, but you can see variables and methods of the outer class if they're static as well from within the shipping mode. Okay, so that's one modeling case. Let's take a look at the next example, which is the member inner class. It's kind of very similar syntax-wise. You also place the class inside another class, but this time you don't stick the keyword static onto it, right? So the difference is that this particular inner class is related to the context of an instance of the order, not the static context of the order, but specific instance of the order. What it is that we're trying to model here, why this class item is inside the order, what's the point? If the class item that represents order item, I guess, is something that you just write separately, like an independent class and a separate source file, whatever. Well, okay, you can do that, but then what stops you from creating an item without creating the order? Nothing, right? If it's an independent class, you can just go and create an item, new item, fine. By placing an item class as a member inner class into the order, you essentially saying you have to instantiate the order first. You have to have an instance of the order. And only then you will be able to create instances of items. So you create here order one, order two, yeah, and then you call some method that, presumably internally, this method creates new item, yeah, and that creates instances of items and maybe stores them in some kind of set inside the order, yeah. So each order will have its own collection of items, And each item will belong to a specific instance of the order. Apart from that, this looks like a normal class. You could have variables, you can have methods, you can have constructors. It's just you embedded it inside an outer class, yeah? The code inside a class item can see instance variables and instance methods of the order. You can, even if they're private, actually. And it can see static variables and methods of the order, even if they're private. Because from the instance point of view, you could see whatever is going on in the instance, and you can see whatever is going on in the static context. Remember, static nested class can only see static context of the outer class, cannot see instances of the outer class, because it doesn't work the other way around. There's only one static context, but lots of instances. So the other way around, the referencing is ambiguous. But from the instance point of view, referencing the outer class or its static context or its instance context is unambiguous in a situation with a member inner class. Okay, so we created here a design decision that forces whoever uses this API to create items in the context of a specific order. Yeah, this is why this is modeled as a member inner class. Okay, next one, a very rare case, extremely rare. I've seen only a few examples of that. And I'm doing Java since version 1, yeah? So for a very long time. Anyway, so this is kind of a situation when a class is declared inside a method. So it's extremely restrictive in terms of its reusability. This class can only be used in a context of a specific method. That's probably why it's so rare. Okay, so defining a class inside a method, why would you want to do that? Well, I guess if you have a very complex algorithm that you cannot just express as a normal logic of the method, because it's so complex, you want to modularize it, you want that algorithm to be wrapped up into the class of its own, but then you're saying that you don't want that algorithm to be reusable. You want that logic of calculating tax or finding rates or whatever to be specific to the order and moreover specific to the managed tax method, and you don't want that code to be callable from anywhere else. It might be like a security concern or very tight restriction imposed upon your code. So you can create a class inside a method. It's a normal class. You can have like variables, methods, whatnot. You can have instances of that class, as you can see, just to create new instance of that order tax manager and call methods upon it. But you can only do that in this method, nowhere else. Yeah. The code inside this order tax manager can actually see variables outside of the class here. It can observe like this sale location, for example. It's a variable. Well, parameter is a variable, really. Yeah, you could address these variables. However, there is a restriction. Variables that you want to observe from outside of the order tax manager, so the code inside this class can see variables outside if they're final or effectively final, right? You don't have to physically put final keyword. Effectively final is a concept in Java that basically allows the compiler to figure out if you never reassign the variable. So the compiler can look at the code and could say, oh, well, yeah, you didn't mark it as final, but you never actually assign anything to it, but just a single time when you initialize it first, so that it will be treated as effectively final, even though the final keyword might not necessarily be physically present. If you want to access some data outside of this class that's not final, well, you just pass it as an argument to a method, right? When you call a method, you can pass parameters, and then you can pass whatever you like. It's the case when you want to access a variable that hasn't been passed as an argument to any of the methods here, just directly see some data outside of that class, well, then that data has to be either final or effectively final. Apart from that, this class can actually observe data in its surroundings. Okay, and it can see the instance variables, and it can see local method variables, and it can see the class static variables, provided they're final or effectively final, or else they have to be passed as arguments to operations of this class. So it's an extremely restrictive way of creating classes, right? It's just restricted to a single method, essentially. Now, this is probably the most common type of inner class, anonymous inner class. It's all over the place in Java, lots of different places. You can see anonymous inner classes used over and over again. And what anonymous inner class represents is an inline implementation of an interface or extension of the class. Here's how we come to realize the importance of anonymous inner classes. Imagine you have a class order. Okay, so it has variables, methods, whatnot, and among all sorts of different methods, let's say it has a method that calculates discount, right? Of course, there are other variables and methods, but whatever, yeah? So there's a method that gets the discount in the order. Now, let's say I have a concept of an online order, and I want to extend the order, and I want to override, maybe in the online order scenario, I have a different way of calculating discount. It doesn't matter what the discount is, just different, yeah, whatever. So some other algorithm. I can override the method and introduce a different algorithm here. But then you look at this class and you're thinking, did I just create the entire class for the sake of overriding just one method? Was it worth it? Like creating a whole separate class and just override one method? But sometimes that's what you want. Sometimes you only want to override a particular method, and you don't really care about, changing other methods. You just inherit them as they are. Well, actually, in this case, you don't have to go and create a separate file, a separate class that extends the class order. You could do better. You could do anonymous inner class. And the syntax of that is that you just create a new instance of order, like you do, like usual. But instead of putting semicolon here, like this is just new order, no, you actually open a curly bracket, you close the curly bracket, you then put a semicolon. And then in between these curly brackets, you override whatever methods you like of that class order. You just override them. Essentially, between that curly bracket and that curly bracket, you just created here a class. This is the class body, except that you didn't call it anything. This class doesn't have a name. This class basically implicitly extends order. When you were saying new order and then providing an actual class body, that class body has no name, but it extends order. And that's how you override its methods. And down, due to polymorphism, when you call that variable order dot get discount, you actually get that particular implementation of the method. Because remember, the lowest implementation of the method down the hierarchy is automatically invoked. That's the definition of polymorphism in Java. Actually, instead of extending the class here, you could say new, and then the name of the interface, and then that body. Well, how come you can instantiate the interface? That doesn't make any sense, because interface is totally abstract. Well, if you actually then provide a body for it, that body will be the class that implements that interface. Anonymous class, it doesn't have a name, but it implements a given interface, and then you override the methods. Well, whichever methods you need to override in that interface. That's anonymous inner class for you. So really useful technique. Here's some examples. Imagine I have a list of products and I want to sort it. And maybe I want to sort products by comparing their names. Or maybe I want to sort products by comparing their prices. Would you create different comparators, right? Okay, you can create different comparators, but would you want to create a separate class every time you have a whim of just sorting the products in a different way? Well, you don't really have to create a separate class every time. You can do it in line. You just say new comparator, use generics, comparator of product, open curly bracket, close curly bracket, and override compare method. And then when you call sort again, you just override it with a different algorithm. This is anonymous inner class defined directly in line inside a call to the method sort, basically. Yeah, because the method sort second parameter is expecting you to pass comparator object, right? And you pass here an implementation of comparator interface, which is your anonymous inner class. It's a typical thing to do with functional interfaces, because you see, the functional interface only ever describes one abstract method that you need to override, just one, which is ideal scenario for anonymous inner class. If you'll have to override 10 different methods, then chances are you probably want to create a separate class here. Just like, normal class implements whatever interface or extends whatever other class and override whatever methods you need to override. But if it's just one method, as in functional interfaces, then constructing the whole separate class seems like a bit of an overkill, right? You can just do it in line, works perfectly fine. Yeah, so it's a convenient approach to functional interface implementation. So there you go. These are various types of classes, nested classes, inner classes that we can basically write a class inside a class. Yeah, so we've covered these types. Now let's take a look at lambda expressions. And what you need to realize is that actually lambda expression in Java is really a way of doing something very similar to what you can achieve with the anonymous inner class. Lambda expressions logic is really, really similar to the anonymous inner class idea. Here's an example of what the lambda expression looks like, feels like, and how it actually works. So, same example. We have the sort method of collection. We want to sort products, right? What do we know about this scenario? Better, let's put it this way. What does the compiler know about this scenario? When a compiler looks at this chunk of code, right, the compiler understands that a collection is using generics, product, right, in this particular case. The compiler knows that the first parameter of the sort method is the collection you would like to sort, and it understands what is the type of the object in that collection, that it's product. And then compiler also understands that the second parameter is a comparator interface, right? So first parameter collection you would like to sort, second parameter something that implements comparator. This is unambiguous because that's the definition of the method sort. So this is your invocation context. The compiler is aware about it. So certainly you could write an anonymous inner class. You can say new comparator of product, and then you override the method compare. Right? Good, you can do that. But you see, the trick is that you couldn't have possibly done anything else here. The only part of this chunk of code in the anonymous inner class that's actually up to you would be the names of your parameters, because you can call them whatever you like. They don't have to be called P1, P2, you can call them whatever you want. And the actual statement, how do you compare things? Well, in this particular case, I P1 get name compare to P2 get name. That's my custom part. This is my custom algorithm, my grounds of comparison. So parameter names and the actual algorithm is what I need to come up with. But you see, the rest of this code is completely determined by the context in which you make in the call. A sort method requires you to implement comparator. It's like you can't really do anything else here. You implement a comparator, and it's a comparator of products because that's the list you try to sort. So the generic from the list should be the same here. And thus, You know exactly what should be the type of parameters. It should be product because, that's what you're sorting through. And then most importantly, comparator is a functional interface. It has only one abstract method. So it's not like you have a choice which method you're overriding. Of course, you're overriding public int compare with two parameters, because that's the only abstract method you're supposed to override in comparator anyway. So all you need to do is to provide parameter names, and you need to write an expression. How do you actually compare things? The rest of it can be guessed by a compiler from the context, and it's pretty unambiguous. It's not like it could possibly be anything else. So lambda expression is doing exactly that. When you create a lambda expression, you do it in some context, in this case, in the context of method sort. And you're saying, okay, well, my parameters are called P1 and P2. And then you put this lambda token, and then you basically write a statement, what do you want to return? So you don't need to write a return keyword. You don't need to put the method body around it. You don't need to put the class body around it. You don't need to write that you override in method compare. You don't need to write that you implement in comparator interface. You don't need to say it's actually type of generics type of product. All of that is unambiguously guessed from the invocation context. All you need to do is write the actual logic, the function that you want to perform. Hence, lambda expressions are often referred to as a functional programming style. They rely upon the concept of a functional interface, the interface that describes single abstract method, which makes it unambiguous what it is that you are trying to override, which method you're trying to implement. And then it allows you to guess, well, allows compiler to guess from the context what exactly is going on. And you, as a programmer, can focus on just writing the expression that is your logic. You don't need to write the whole thing about the anonymous inner class around it. So this is it. That's what the code does. Yeah, that's your lambda expression. Let's take a look at practices for lesson 10, which cover nested classes and lambda expressions. Now, in this practice, you need to change the design of the product management class to create a static nested helper class to encapsulate all the management of the text, resources, and localization. Now, this is a strange practical exercise because you're not actually in that section of the practice, you're not actually writing much of a new code. You're almost only just kind of cutting and pasting it. You're moving the code, you're refactoring it, you're changing its location. So code that's currently in the product manager class needs to be kind of alienated, moved into a separate class, nested class. Now, the reason for this design, for this change in the design, is to separate the business logic of the application, what you do in terms of storing products and reviews and doing that part, from the part that visualizes the information. For example, applies the locale, or parses values, or formats values, or print reports, or anything like that. So that's the first part. And then there's another part of this exercise which actually implements different sorting options for products using lambda expressions. Okay, so now there is a strange thing about this exercise, as I say, yeah? Because you're not really writing any code in the first part of the exercise, you're mostly just moving the code around, you've got a choice here. You can actually do the exercise properly, in which case you follow the instructions of the lab 10.1a, and that tells you how to cut the code, where to paste it, how to rearrange it. Or alternatively, you can skip the 10.1a and proceed to 10.1b, where that is already done for you. In this case, the assumption is that you take in an already refactored code where the code has already been moved into the static nested class, and then you just sort of, read through that transcript of 10.1b exercise to understand what the new code is doing and why it was refactored like that. So I'm going to show you how to actually follow the practice 10.1a, but just in case, if you don't want to do a lot of cut and pasting, then you can just read through the transcript of 10.1b. Regardless of which way you do it, you still need to do the exercise 10.2 after that. So either you finish 10.1a or you load essentially a solution and read through that in 10.1b, but you then do the 10.2, which is the exercise that practices lambda expressions, right? Okay, well, let's start with 10.1a. The assumption is that you finished the previous exercise for lesson 9 and that you decided to actually do the lab, step by step. Right, if you finish the previous exercise, you don't really need to open the solution. You can just continue in a previously created project, or else you can open the solution for practice 9. Now, your job here is to create a static class, a nested class called resource formatter. So this one would be responsible for formatting values, applying localization, and we'll take this functionality. It's currently in the product manager, and we move it to this resource formatter. So let's open the product manager, and just anywhere, well, doesn't matter really, put the resource formatter static nested class. Just nicely realign the code, and we'll be moving code inside here, so we'll be cutting the code from the product manager and move it into the static nested class instead. Right, so what do we need to move? We need to move the declarations that relate to the format, into the locale, to resource bundle, to date time format, to number format. Fair enough. So let's find these variables. Locale, number, date format, resource bundle, cut them, right? You retain the part that deals with data, like product map. That's fine, that's still in the product manager, but we cut and we paste the other components inside this resource formatter. Okay. Of course, now we need to initialize them. Previously, these were initialized from the constructor of the product manager. But now we're initializing them through a local method, which we need to add to the resource formatter. In fact, we can add that as a constructor of resource formatter, and that's precisely what you do next. So you create a constructor for resource formatter to accept the locale, okay, format it nicely, and then move the initialization code for the locale resource date and money format from the constructor of the product manager, where this code currently resides, here, from the product manager constructor, move that to the constructor of this nested class, here, to the resource formatter constructor. Okay. So we're initializing all of these resources. Same logic, we just moved it from one class to the separate class, which is nested. Okay, so we did that, Now what? Now we need to add a method to format information about a product. So we'll have a dedicated method to do the formatting of product data. That's the signature of that method, return in string, accepted product, which kind of makes sense, and put that into the resource formatter. Of course, we need to add more logic to this method, but we'll deal with that in a moment. So now we have a dedicated method to format the product. How do we format the product? Well, actually, we already have the required logic. This logic comes from the print product report method, which is currently doing that formatting. Let's check it out. So what's going on in print product report? We have here the format for the product. Yeah? There it is. That's the chunk. Well, appending it to the string builder, but obviously, well, we just format the product here as an argument within the string builder append method, right? So if we take that out, so obviously something needs to go into the append method in a moment. Yeah, but if we take that out and we put that logic into format product method, and we return basically the formatted result. Let's just make sure you put correct semicolons at the end of the line. Yeah. So there you go. You use this locale, given product name, price, rating, best before dates, which you extract from the product. All of these properties, you use the resource bundle here that you've loaded, you use the formatters. So all of that was previously done in the method that printed product report, right? But now we can actually use it inside a method format product. So we can call it later, yeah, from print product report, I guess. Okay, so we moved that code. Now the same thing needs to be done for formatting of the reviews. So we add a method to format reviews. Again, same idea, yeah. So what exactly goes into the format review method? Well, I guess that message format here. When we were printing product report, we're printing reviews as well. Again, the logic will have to be sort of added to these append methods, which is kind of currently missing, but we'll figure it out. So we're formatting the reviews, right? And again, we need to make sure we return the text value of the formatted result. Okay, so the reviews, we sorted them out, yeah? Now, one more thing that we could add to our resource formatter is the method called getText, just to get any other text from resource bundle that does not require formatting and substitution of parameters. To remind you what's going on in resource bundle, we've got the product message, which requires us to substitute several values. We've got review that requires us to substitute a couple of values, but we may have other key value pairs that require no substitution, which we can just get as text. Yeah, there's no need to substitute any parameters. So that means we could have a method to just simply get the text and return the resource from the resource bundle pretty much as is. And that is the next thing you're adding to the resource formatter. Okay, so we can format the product, we can format the review, and we can get any other text from the bundle, basically. Now, inside the product manager, what we need to do is create resource formatter instance. Probably more than one, because we could initialize different instances of resource formatter for different locales that would like to support. Right? This could be done with a simple static variable, which will store the map of different resource formatters per locale.